So today we're going to look at cloud-based services and interacting with cloud-based services as a backend database for your applications that you may develop either in Python or in ArcMap and Python through tools. So we're going to be looking at cloud services, a particular cloud service, and it's good to know what cloud services are about. And basically, cloud services are services that you can use, just like WalkScore that we used last week and GeoPy. And there's all kinds of cloud services. We're going to be looking at a database cloud service in this particular lecture and in the accompanying exercise called Firebase. And these are software as a service. So a database is a type of software that is generalized in that a database can be used to store any type of data. There are local ones. You could have an Access database, even Excel as a database, and stuff like that. Or you could have a cloud database that's stored off-site, and that makes it somewhat robust, and because it's unlikely to be destroyed if your hard drive breaks down or something else happens with your hardware, if you had your own server, for example. And they're provided by third parties. So, for example, Google provides a backend database cloud service called Firebase, which we'll be looking at today. And it's a software as a service. So it's a database software that is provided as a service on demand and is based on transactions. We'll be using the free tier of it, but if you had a large database online through that particular provider, well, it might cost some money every time a transaction happens. Transactions are when you do something in the database or the user does something in the database, for example. And the advantage of software as a service in the cloud is that as long as the user has an internet connection, they could utilize your software and your database in the cloud. They don't have to know anything about the backend, which is this area here. And so they can concentrate on their particular tasks at hand without having to worry about coding or data storage. Firebase is the one we're going to work with today. So Firebase is a Google product, and it offers backend database systems of various types. So with Firebase, we can create a database online that is usable anywhere on Earth as long as you have an internet connection. And that means that the data that's stored there could be used by a GIS developer like yourselves through a tool for users to interact going up and down to the cloud and whatnot. So Firebase is here. That's the URL. So you need to go there and sign up for a free account. And there's a slide-by-slide demonstration in a couple minutes about how to do this. Once you have a free account, you create a new database called a real-time database. And then we utilize the URL to that database to store and synchronize, change, modify data in the cloud, so that it's safely in the cloud somewhere and is not stored locally. Now, before we get into more about the database itself and Firebase, we have to just do a quick review here of dictionaries. So if you recall, dictionaries in Python have the squiggly braces like that, and then they have a key. I'll draw that better. Key and a value separated by a colon, and then the next key value pair, etc. So here, for example, we see this dictionary called smalldic has 1 as the key, and then :4 is the value, and then 2 is another key, and then :5 is a value, and they look just like that. So it's called a dictionary. You can check if something's in a dictionary, see if the key is in there, saying 2 in smalldic, that would return true because it's in the smalldic dictionary. You can get a value using the get method, so on the actual object itself. So smalldic.get, and then in parentheses the key name, like 1, and that would return the value 4 and print it out. And of course, you could manipulate values of various keys if you know what they are. So for example, if we have two numeric values in key 1 and key 2, so we could simply, if we wanted to utilize those directly, I could say small dict.get1 times small dict.get2, and the result would be 20. So it would be printed out there, which is 4 times 5. So dictionaries, like everything in Python, are objects, and they have methods. Some are used more often than others. This is just all the methods again of the dictionary. So you can just ask, for example, keys. So if you just want to know what all the keys are, you could say small dict.keys, and it will list all the keys as a list object. If you just want all the values as a list, well, you could say my small dict.values, and that will provide you with all the values in the dictionary. And these are the examples here. So small dict.values, and print x would print 4 and 5 as a list. You can add new values to a dictionary with the update method on the dictionary. So for example, if I want to update small dict with a new key value pair, notice the new key value pair has to be a dictionary as well. So it has to be in a dictionary format that you can see right there with the squiggly braces. So that's a new key value pair, update, small dict, and then small dict would have 4, 5, 1, 4, or 2, 4, 3, 5, 2, 1, 4, or what is it? Anyway, you get the the idea. It would just have that as another key value pair in the dictionary. I can't remember what the keys were now, or I think they're 1 and 2. So 1 was 4, 2 is 5, then you'd also have 3 is 7. If you want to retrieve just specific key values pair like 3 and 1, you can do that quickly through iterating over the keys. So for key and key list, when you have the key list you want 1 and 3, and then you say, okay, small dict.get key, and that will add, in this case, 7 and 4 to that list object. So that's again using list comprehension. Now, the dictionary is shown up here. The general format of a dictionary is the same as the general format of a JSON object. Remember, that's a JavaScript object notation. So it's a common way to store data and to communicate data through the internet because it's very simple. What it's showing here in this object, so the object is a JSON object or a dictionary object. We have squiggly braces, again, around everything. And then we have a string. Remember, all the keys have to be strings, so they have to be in quotes. And then comma, or not comma, colon value. And then if we have more than one thing, comma, and notice how it goes back in there, string colon value, comma, string colon value, comma, until you're completed your dictionary of whatever you want to have in there. And so that format is the same for JSON, which is JavaScript object notation objects, and Python dictionaries. So they're almost interchangeable. And that's small dict again that we see there. Now, this format is particularly used in what we call NoSQL databases. So a NoSQL database is what's called or it's called NoSQL because you can't use SQL statements to go and query it. It's structured as dictionaries or JSON strings. You can still query, you can still modify, add, delete, and everything like you would with a regular database, but it doesn't have. You can't use, for example, SQL, so structured query language, with that type of a database. It's made for simple data storage and retrieval. And Firebase is based on these things. So Firebase objects are JSON objects. And again, Python comes with a package JSON that can manipulate and go from dictionary to take a dictionary in and create a JSON, properly delimited JSON string. And we've seen this already, so import JSON. For example, json.dump small dict, and then you print it out, it would be a single string, which is interpretable as a JSON string from a dictionary with things properly delimited. And if we have a JSON string, we can load it into a dictionary in Python with json.loads. So you can go back and forth with that particular JSON library. And I showed you this last week where we looked at the JSON online editor. So you can always check your, you can copy and paste your dictionaries in there and stuff and see what they look like in tree view, for example, if they're properly structured the way you want them to be structured. To start and create a Firebase backend cloud database, log in with your Google account. Use the same one that you used last week, the one that you created when we were looking at the GeoPy, for example. But you start here on this page with Get Started. Then choose Create a Project. Here on this page, type in whatever you want your project to be called. In the following examples, we will be dealing with a tree class. So maybe you want to have it something like the name tree in there to remind you of what that will be, because this will become part of the project's URL. And so you want to type whatever you think is useful in there for you. Then accept the terms and continue. You'll probably be asked there's a couple screens about data analytics and whatnot. Just click OK or whatever you want for those. It doesn't matter. After that, it will start creating your project. You'll see a screen like that. It'll be animated. And when it's finished, you'll see the 3 dots in a circle like you see right here. And then continue. Finally, you'll see a page with a menu on the side, or a hamburger drop down like that. It doesn't matter what shows on the left-hand side over here, right? All you care about is finding that symbol on the page and clicking on it to create a web application. Then give it a nickname. It'll ask you to give it to register the app, give it a nickname. You can skip the Firebase hosting. That's not something we're dealing with. And once you give it a nickname, just click on Register App. It will show you this next. And this is a bunch of text. And you should copy and paste that into Notepad or Microsoft Word or whatever, because it has important information such as the URL to your project, which you need to use in the following slides if you want to go along and test the code. So once you copy and paste that into Word or Notepad like this example, then you just have it available so you can use that to replace in the following slides the URL that I have for my project with this one, which is your URL for your own Firebase backend cloud database. Then you'll come up to a page like this, and you'll want to click on Build. And you'll see it says trees, obviously, right there. That's a nickname for your app, not the URL or anything. So you click on Build, and then choose Real-Time Database. Choose Create Database. And then choose Start in Test Mode. What you see here might be a little bit different. I just have this example showing true and true. And that just means that anyone on the internet that has this URL for my database could read and write to it. By default, you'll have something here that limits it to 30 days of open read and write, which is fine. So these are the rules basically for the database access. And there's a whole help file just on how to deal with rules and certain types of rules and what to do with them for your database. But these are the basic ones that are required for your database to be able to be accessed by its URL from a client API like in Python. So don't choose this one. Then it'll return you to a thing that looks just like this. So a page where it'll have your URL to the database up top, and then it'll give just this part, the name of the project, without the Firebase input-output.com. So that part's taken off and just shown here. And that's the root of your real-time database. And to start off, we're going to import JSON, select the mydata.json file that you've downloaded from the course module. It might give you a warning that everything's going to be overwritten. That's fine. Click import right here. And then you'll see that your database is populated. And you might see that this looks a bit familiar because it's just JSON. This is a NoSQL database. So it's an unstructured database with that it will basically is created with using JSON structures or dictionary structures for your data objects. So you can create a data object however you want. You're not constrained to like a SQL database where each data item has to have a type, a column, etc. This is a different way of doing it and a preferred way for quick and efficient responses. So you'll see that populated, and you can open and close the nodes if you want, just to see what the default data that is in there for this example. This is the URL to your database, and you want to note that this is mine here. And again, for the stuff in the following, you'll need to use your own URL, which will be up there. And you just replace whatever mine are with yours for the examples. So the mydata.json file or JSON file just looked like that. It's just a text file that looked like this. And then once it was imported into Firebase, using the import JSON with those 3 dots that we just did in the previous slide, now it looks like this. So it has a root node and then a bunch of children nodes. So in the children nodes, we have a UID for each entry. This is generated because I created this database in there and exported it just to give you something to import. These are Firebase generated keys. So they have these long names, you know, with just random characters in them. And you'll see those in the file there. And we'll also see when we add data through Python to this backend database now, it'll add more keys. It'll add more items as long as we add them in. So every new item that's added will get its own unique key. And that's just the Firebase key. It's a way to cross-reference things, you know. Now, at the top of the database, you'll see data, which you're on right now, and then rules. Click on rules, and then it'll show you something that just says rules, read, write, and nothing else. In other words, just replace that by copying and pasting this. And the reason I have it like this, I have read auth equals null. That's so if you wanted to put your authorization or your API key in there, you could at some point later, so that other people can't get to it. And then there's this thing called trees here, and this is just building an index. So it's indexing the trees on the field's species and height. And that just allows, for example, for queries and stuff to take place on those particular fields if you wanted to do that. So that's the only reason this is different from the one there, although you don't need to do that right now. You could just leave the default that's there. But you can also copy and paste this one in there if you want to. So the Firebase web apps use a REST API. And REST just stands for Representational State Transfer API. It's a type of application programming interface that utilizes URLs to make transactions with the backend database. It's the most common type of API used on the internet today. So using standard URLs such as this one that you see here, where it has your URL for your database, and then it has this other stuff tacked on, and we'll see what that is in a minute. But it says, in this basically it says from trees.json, because remember it's a JSON file or string that is stored on the backend database that we created, the real-time database. So with trees.json, sort by species and start at pine. So it would, this particular call would sort the current, or would return a sorted dictionary alphabetically by species starting at pine. And that's just kind of what this says. We'll see that in a little bit more detail later. But the important thing to know is that it's URL based. So REST APIs are URL based. You can access Firebase that way from JavaScript, from Python, or any language that has some access or a library for creating REST API URLs. And that allows, of course, for things to be sent back so that we can see stuff on websites. We can upload data and use it in a mobile app or through Python, download data to run your own analysis, query, add, delete, modify data in the cloud backend, and export all of your data if you want to use it in another program. So the REST API allows for basic transactions to take place regarding data that's held on some server. So we look at here, which is what's called a GET request to a REST API, and a GET request is something that will provide us with information back from the server from our database. And it starts with a scheme. So the scheme is just the HTTPS in this case, which is Hypertext Transfer Protocol Secure. Sometimes that could be a different thing, like HTTP without the S on it. But in our case for Firebase, it requires us to have the HTTPS for a request to the server. Then we have the host. That's the URL where the data is hosted. In our case, it's hosted for our particular database in that location right here. That's your URL, for example. This just happens to be one that I made. Then we have the path on the system or on the server, so that within that particular database, the server knows where to look for the data. In our case, we have here trees.json. We could have multiple databases in there. So trees, we could have something about rocks or whatever. And we have to tell the server where to look, so it just says trees.json, because remember, a real-time database is a JSON string on the server. So trees.json. And then we have what's called a query string. And the query string has basically pairs of name and then some value. So name, like order by, equals species means to sort by species. And then we have a start at equals pine, to start at pine, and then order by species. Now, these are two separate things, more or less, and we put them together with an ampersand right here, the and symbol. And that's how you create queries using multiple criteria, like we have in this case. So here, for example, you can try this on your own database. If you just say HTTPS, and then, well, obviously just the URL to your project, to your database, and then /.json, that will return the entire database as a JSON string to your current window that you called that from in your browser. So you can see here, if I do that, I get my JSON string back down there. I could say return from .json, order by $key. So $key is a special value within the database. That's the values given to each of the trees as unique IDs. So those funny looking ones with lots of letters and numbers in them. And so if I order by key, then it comes back just ordered by key, which happens to be the same order as the JSON file in this case. If we want to return all data, let's say that are pines within the data set. So we can say here order by species ampersand equal to equals pine. So that equal to equals has to be like that. Even though it's kind of redundant to have an equal to and then an equal sign, it has to be there for the separation of the name and value. So you'll see that even in order by equals makes more sense, but here it's kind of funny. But that's the way it works. So if I ran that, and again, you could try it putting your URL in there in that part, it'll just bring back wherever the pine is. So in this case, there was just one pine in the database. Here, returning all the data ordered by species spruce. So order by species equal to spruce will give me just spruces back. And there's 2 spruces in the data set, so it gives me a JSON string with 2 spruces. So to use Firebase in Python, we have to use the Python Firebase API. And there is no official Firebase Python API made by Google. So there's a number of languages that aren't supported directly by Google or Firebase as part of Google. So the Python interface to Firebase's REST API, we use a third-party one. And we can look at use instances of this. So for Firebase, we have to import it first. So the first thing you do is in your Python is import Firebase as Firebase. Or you can, if you want to call it something else, you can call it import Firebase as FB or something else. I'm just using Firebase as Firebase here, just so that it's always clear when I'm using something from Firebase in my code. Then I'm going to have a string that represents the URL to my data set. And that's again the one you can find in your notepad. If you copied and pasted it there, you can copy and paste it here. And remember, it has to be a string. And I just call the variable here my Firebase URI for Universal Resource Indicator. And then I'm going to create my instance of the Firebase class using my unique URI right down here. And I say Firebase.Firebase application, and then my Firebase URI, and then none for the second argument. And that now creates an object instance of Firebase. So we can now use Firebase from Python. The first method we'll look at in the Firebase API is the get method. And the get method allows us to retrieve the data by minimally using just 2 arguments. The first one is a path to the database. When empty like this means all. And then the second is the name of a node that we might want within the database. For example, coords if you wanted that specifically. But in this particular case, we want all the data just to be returned to result. And so we say myfirebase.get and then just with the empty quotation marks and none. And that will return, when you look at result, it'll return that particular JSON string. If we only want data in a specific path in our JSON string online, we can say, let's get it just from trees. So we put as our second argument, instead of none, the name of that node that we want. And it's trees, and then it returns, once you print the result, returns this. So we don't see trees out here anymore. We now just see a dictionary with the unique identifiers and then the information for each of the species for that unique identifier. Likewise, if we know of a specific identifier and we know the value of that specific identifier, we can also just say trees / the unique identifier. And that will then, once we print it, will give us that. And that happens to be that particular one, that particular data for that particular identifier right here. So again, the result is just a Python dictionary. Now, we can use a patch method. So the patch method is important because it allows us to change the values within an existing record or data item in our Firebase JSON string. So it takes two arguments, the first being the path in the database that we want to change, and that includes the name of the node or child node to be modified. And the second is a dictionary in the format of that node that we're changing. So we'll look at an example here. So let's get and store in result the trees with this particular identifier, same one as on the previous slide. So we get that in result. So result holds a dictionary. And in our dictionary, we know there's a chords and X. There's also a Y. So if we want to now change the value of X for the X coordinate that's in result, result again is a dictionary. So this is key and then child key. And we then put a value, 66. Once we've done that, we then use the patch method right here. So my Firebase.patch, and then the same exact identifier and path that we used to get, we put right here as the first argument to patch. And then we send result. Again, remember it's been modified there, and then we send that back in a modified form, and it replaces that part of the dictionary, thereby modifying the data that is held on Firebase. So that patch method is useful in that regard to change existing data. And you can see that here. So we saw 45 change to 66 right there. Here's another example of the patch method. In this case, we want to change the height value of one of the child nodes for this second item right here. So for that second item, we first get the node that we want. So that's going to get this part right here as a dictionary. And in there, we have height as one of the keys. So we say result, we get that, and then result key height is 15.2. And then again, we patch it back. So we then send back the exact same to the same path in the JSON string right there, the result that's been modified, and it changes it online. So again, just visually, we get it, goes to the result. We change the value of result locally, so that again, that's just a local change right now in a dictionary. And then we patch it. And we see that it changes instantly in the backend database in real time. Now it's 15.2. The next method we'll look at is the post method. And this is when we want to create a new data item within our backend database JSON string. To create a new item, I'm going to be lazy here. I'm just going to grab one of the existing trees. So I use my get method here, and I just get the tree at that particular identifier. And again, this is just for convenience. Then I print the result itself, which is a JSON string, and then I copy and paste that JSON string into my dict right here. So again, result, I don't show it here, but I just print result, so I can copy and paste the whole result and assign it to the variable mydict. And before hitting the enter key, I can change any of the values I want. Because again, all this is basically a schema or template at this point for my next tree that I'm adding in. So it doesn't matter what that was originally. Now I can put in the coordinates for that tree. I can put its height, and I can put its species at that point. So I'm just changing things right in the copy of the tree I just took down from Firebase. And once I've done that, I post it to trees. So again, that's the path I want to post to, because again, this here, I've gotten just a single tree. And this is the dictionary for a single tree right here, which I've modified things in for my new tree, and I then post it, like so, into the trees folder. And it will automatically create a new and different unique identifier. So there's our trees, and once the post happens, it creates that. So it creates the new item, and then we're done creating a new item. When I do post something using the post method of Firebase, something is sent back. So if I say result equals my firebase.post, and then into the trees node or path, and I put that dictionary right here from the previous slide. So what is sent back is the new unique identifier that was created in the database. So if I print the result, I will see a list, I should say a dictionary with name is the key, and then the value will be the new unique identifier for that new record, basically, in the JSON string online. I can store that by getting the value result from result. Name is the value for that key. I should say name is the key for that value, and then I can store that in just a variable called ID, for example. So then if I was doing this multiple times, for example, if I was, let's say, putting a whole bunch of points, trees up online, I could store this instead, and I can make a list out of ID, for example. I can make a list out of the IDs, so I'd have the IDs, the Firebase IDs for each of the new items that I posted online. And that's quite useful, because then you have a way to modify things later on. Because again, to modify an existing record using patch, we need to know the ID. So if you're uploading multiple things, you should save the IDs in a list in the order of upload, and then you would have a record of those IDs that you could then use later to do things like change the values of particular trees. So here's using a bunch of things together, let's say. So here I start off with a new record. So again, it's just a dictionary of a particular tree without the unique identifier. So I post that, and the result object, again, gives me the name and value as the new key that was posted into this database as a new item. So in result, we have the unique identifier of the thing just created. Here, then, if I wanted to change that, right? So let's say I wanted to change the one that I just uploaded. Well, I can use my get method with trees and then the result name. And again, that's the new unique identifier. So I'm just using plus here. You could use the string squiggly brace dot format as well if you wanted to make that particular string. So I then get it back. The idea here is not that I just make it and then get it back right away. The idea is here that I can get it back, any particular record back, if I know the unique identifier. Once I have that, then this is again a dictionary in Python. I can go to the species, let's say, and change it to catalpa. Maybe it was spelled wrong before, like we see right there. So I change it to the right spelling. Then I patch. So I patch again to the same directory or folder or path, my modify result, which is the modified dictionary. And now if I print patch result, it would show that I have now spelled that correctly. So again, having that unique identifier is critical. If you create something, you need to store that unique identifier somewhere so that you have access to that something that you just created without having to manually try and find it later on. So modify the result, correct spelling, and then patch it back, and it's done. Since we're creating trees, it might be very useful to have a class. We'll just call the class myData in this case. And this particular class takes in species, X, Y, and height, all the items that are necessary for a tree. I've also put in a getCoords method, so it just returns a dictionary with just the coordinates, for example, X and Y. And then there's a makeDict method that I've created here. So it creates an empty dictionary in longdict, and then updates species, self-species. So whatever you send to it as the species will go there in the second item. Height, self-height, chords, self.getCoords, calling that particular method to take the X and Y and put it into the right sub-dictionary. And then returns the longdict. If I want to use that to create a tree, this is one way I can create new items, and quite easily I can say M equals myData, which is now an instance of a tree, ash, with X is 6, Y is 8, and height is 18. And then I say .makeDict, and that then creates a dictionary of the entire thing by calling that method. And it puts it in the format that's required for our online database. So I can then just post M like that to the tree's root with a Firebase post method call. And then it just prints out this was uploaded to the database. So something like that, having a class that produces a dictionary that's in the same format as a tree item within our online Firebase JSON string in the real-time database is quite handy, as you can see. I don't have to then manipulate long strings or long JSON strings like we did in the previous slide. I can just create one with one line of code and then post it. And of course here, I would probably want to save that right to a result so that I could have access to the ID. But in this case, I'm just showing just a straight post in this case as an example. How about having that functionality built into the class? So instead of creating a tree and then having to use the post method of Firebase, why not have that right inside as a new method? So here I create a method called upload. And in here it imports Firebase because, again, maybe every time we make a tree we don't want to interact with Firebase. So this class or an object can be used in other instances, and if we want to then upload it at some point, we can just call the upload method with with no arguments, just a parentheses. And in here, if it's necessary to call the upload method, it imports Firebase, creates the application, and notice the Firebase URL is part of the is one of the properties of this class or variables, and the base node trees, where trees go. So those are two things that are built into the class. They could be variables up here if you wanted to share this class more generally with other people as a way to interact or upload trees to Firebase. So we create the instance of the Firebase class, the object called the Firebase. And then we create a JSON string, which is just the self makeDict, which it calls the makeDict right here, and creates that variable called longdict and returns it back and stores that in FB JSON. So Firebase JSON right there stores the longdict right here. And then once we have that JSON string, we know that's already in the format for Firebase. So we post it right in here. We get the base node, trees, because that's where we put our trees in this database, and then the dictionary. And it prints, was uploaded to such and such. So all I have to do then, if I want to both create a tree, an instance of a tree, and upload it, right here, O is my data. I'll make a Buckeye, and the X, the Y, and the height, and I just call .upload, and immediately it's uploaded into my particular database. Something like that can be quite useful if you were, let's say, looping over a point feature class, and you're uploading each of those features and attributes to your online database, because then you can just get the data from the cursor, populate the class, and call the upload at the same time within the same loop, and it makes your type of or the type of code very, very succinct that way, because you don't have to have all this other type of code inside of there. You just call the upload method of the class. So complete exercise 9, and you'll have 2 weeks to do that before you hand it in, even though it says here for next week.